Imagine waking up in a world where cars drive themselves, where robots handle a huge share of physical labor, where homes generate and store their own power, where factories run almost without human hands, and where one thread of artificial intelligence quietly connects all of it together. That sounds like science fiction, but what if that future is already being built right now, piece by piece, in plain sight? There is one company betting its entire existence on stitching all of those pieces into a single machine. Not a car company, not exactly. A company trying to become the operating system for the physical world, and that company is Tesla. Most people still think of Tesla as an electric car maker. That framing is outdated. Tesla's own long-term planning documents, what the company calls its master plans, describe something much bigger than vehicles. The third master plan talks about building a sustainable global energy economy through electrification and large-scale storage. The newest plan goes even further, describing a fusion of manufacturing and autonomy meant to bring artificial intelligence into the physical world through solar power, batteries, self-driving vehicles, and a humanoid robot called Optimus. Here's the golden fact almost nobody is talking about. Tesla is not trying to win one market. It is trying to own an entire vertical stack, from the electricity that comes out of the sun, to the battery that stores it, to the chip that processes it, to the robot that acts on it. If you strip away the marketing, Tesla is attempting to become the picks and shovels company of physical artificial intelligence. And almost no automaker in history has tried anything on this scale. So let's break down the machine Tesla is actually building, one gear at a time, because none of these pieces make sense alone. Start with energy, the foundation of everything else. Tesla's solar business generates electricity. That electricity gets stored using two very different products. Powerwall is the home version, a battery about the size of a large suitcase that keeps your lights on when the grid goes down. Megapack is the industrial version, a battery so large it is measured in shipping container units, designed to stabilize entire regional power grids and smooth out the ups and downs of renewable energy. Picture a battery large enough to power a small city for hours, sitting quietly in a field, waiting for the exact moment the grid needs it. Now layer in artificial intelligence. Tesla has been building specialized computing systems, sometimes referred to as Cortex or Dojo, meant to train the software that powers self-driving. This is where things get interesting because that same software architecture is not just for cars. The same neural networks trained to recognize a stop sign or a pedestrian are, according to Tesla, part of the same technological lineage used to help Optimus recognize a doorway or pick up a box. That brings us to full self-driving, or FSD, the software Tesla says is the foundation of its autonomy ambitions. Right now, FSD is in early commercial deployment. It is not fully autonomous in the way most people imagine when they hear the word self-driving. It still requires supervision in most jurisdictions. But Tesla is using it as the training ground, collecting driving data from its fleet on public roads every single day. Data that in theory keeps making the system smarter. If FSD matures the way Tesla predicts, the next layer is robotaxi, a fleet of vehicles that could operate as autonomous ride-hailing services without a human driver behind the wheel. Right now, robotaxi exists only in pilot form in limited markets under heavy scrutiny. But if it scales, transportation stops being something you own and starts becoming something you simply request, the same way people request a car through a ride-sharing app today, except there is no driver on the other end. And then there is the piece that sounds the most like science fiction of all, Optimus, a humanoid robot designed to eventually perform physical labor. Right now, Optimus is still a company roadmap item. It is not a mature commercial product. But Tesla's argument is that if you can teach a car to see and navigate the world using cameras and neural networks, you can teach a robot to do the same thing, except instead of driving, it walks, grips, lifts, and works. Here's where the investigation deepens, because the real story is not any single one of these products. It is the fact that they were never designed to exist in isolation. Solar and Megapack fund and power the factories. The factories, built with heavy automation, produce the batteries and the robots. The vehicles on the road generate the data. That data trains the artificial intelligence. The artificial intelligence improves both the cars and the robots. And the robots, if they work, eventually reduce the cost of manufacturing everything else in the loop. It is a closed circuit, energy feeding computation, computation feeding autonomy, autonomy feeding manufacturing, and manufacturing feeding right back into energy and robotics again. So the question becomes obvious. If this really works, what changes? Start with transportation. Analysts at firms like Morgan Stanley and research groups including McKinsey have argued for years that autonomous vehicles and electrification are not small incremental shifts. They are system-level shifts capable of compressing costs across entire industries. If autonomous ride-hailing becomes cheap enough enough and reliable enough, fewer people may feel the need to own a car outright. Ownership could slowly shift toward access, the same way many people stopped buying music and started renting access to it through streaming. Now think about logistics. If autonomous trucks and delivery vehicles become viable at scale, the cost of moving goods across a country could drop significantly because you remove one of the largest expenses in trucking, the driver's wage, and the limits on how many hours a human can legally stay awake behind the wheel. That is not a small tweak. That is a restructuring of an entire industry that touches nearly every product you buy. Then there is energy. If distributed batteries like Powerwall and grid-scale systems like Megapack spread widely enough, regions with heavy solar and wind investment could become less dependent on traditional fossil fuel plants that only exist to cover peak demand. Tesla explicitly markets Megapack as a tool to stabilize renewable heavy grids. If that promise holds up at scale, it does not just change how homes get power, it changes how entire national grids are engineered. And then, the part that makes people uncomfortable, the labor market. The most realistic outcome experts point to is not robots replacing every job overnight. It is a sharp reduction in demand for repetitive, structured physical work. The kind of tasks found in warehouses, certain factory lines, and some delivery and service roles. Optimus remains unproven at commercial scale, so any real labor disruption stays conditional on Tesla solving massive problems in cost, safety, and reliability. But if even a fraction of that vision becomes real, entire categories of physical labor could look completely different within a couple of decades. Which industries are most exposed if this plays out? Trucking and local delivery sit near the top of the list because autonomous driving directly threatens their core cost structure. Warehousing and manufacturing follow closely, since robotics and automation are aimed squarely at repetitive physical tasks. Vehicle repair and insurance are also on the list because a world with fewer accidents due to autonomous driving and fewer moving mechanical parts due to electrification needs less of both. Even utilities and fleet operators could be reshaped, as distributed energy storage changes how power gets generated and distributed at the local level. Now here is a provocative question worth sitting with for a second. If a single company actually pulls off vertical control over energy, computation, transportation, and physical labor all at once, is that a triumph of engineering? Or is it a level of concentrated industrial power the modern economy has never really had to deal with before? Let's talk about who benefits if this vision keeps advancing. Companies that supply the raw components of this build-out tend to benefit regardless of whether Tesla specifically wins. Chip makers like Nvidia benefit if demand for high-end training and inference hardware keeps climbing. Advanced semiconductor manufacturers like TSMC benefit from the chip fabrication side. Battery suppliers such as Panasonic and CATL benefit from rising demand for battery cells. Industrial automation giants like Siemens and ABB benefit as more factories move toward robotics. Even companies focused on power management electronics like Texas Instruments stand to gain as the entire system becomes more electrified. On the other side, industries whose economics depend heavily on human driving, human labor, or fossil fuel throughput face real pressure. That includes parts of the oil industry, traditional taxi and ride-hailing companies built around human drivers, layers of trucking intermediaries, some auto dealership models, and manufacturing operations that are difficult or expensive to automate quickly. But before this starts to sound like inevitable destiny, we need to talk about the obstacles because they are enormous, and they are the reason skepticism exists at every level of this story. Full self-driving still faces real technical limitations and a patchwork of regulations that vary from country to country and even state to state. Optimus still faces serious problems with dexterity, the fine motor control needed to manipulate objects the way a human hand can, along with unresolved questions about safety certification, and critically, the cost of building these robots at a price that actually makes commercial sense. Large-scale artificial intelligence infrastructure is extremely expensive to build and run, and much of it still depends on external suppliers for advanced chips, which creates exposure to global supply chain shocks and geopolitical tension, especially around semiconductor manufacturing. There is also the risk that one weak link breaks the entire chain. This is not a portfolio of separate products. It is presented as one interconnected system. If autonomy stalls due to regulation, the robotaxi business stalls with it. If battery costs do not fall the way Tesla projects, both vehicles and energy storage products lose their competitive edge at the same time. If Optimus never becomes commercially viable, an entire pillar of the long-term labor thesis simply does not materialize. Even Tesla's own materials acknowledge that several of these goals remain difficult, unresolved, and long-term rather than solved. So what do the experts actually say about all this? There is broad agreement, even among skeptics, that Tesla is genuinely trying to become an artificial intelligence-driven industrial company rather than a traditional automaker. Supporters, including well-known investor Cathie Wood, argue that autonomous ride-hailing and humanoid robotics could unlock enormous value if Tesla executes well. More cautious analysts tend to push back hard on timelines, pointing out that Tesla has a long history of announcing dates that slip by years, not months. Even voices from outside the automotive world weigh in on the bigger picture. NVIDIA's Jensen Huang has spoken broadly about artificial intelligence eventually moving into the physical world through robotics, a trend that aligns conceptually with Tesla's direction. But that broad agreement about where the technology is heading does not mean Huang, or anyone else in the industry, is endorsing Tesla's specific timelines or promises. There is a difference between agreeing on a destination and agreeing on how fast or even whether one particular company gets there first. Here's the second provocative question worth asking. If artificial intelligence, robotics, energy storage, and autonomous transportation really are converging the way multiple independent analysts suggest, does it actually matter whether Tesla specifically is the company that pulls it off, or is Tesla simply the loudest, most visible experiment in a shift that was already coming? Let's zoom out and look at where each piece of this vision actually stands today, stripped of hype. Megapack is already operating commercially and generating real revenue. Powerwall is already operating commercially in homes around the world. Solar is already operating commercially, though its scale and profitability vary significantly depending on the market. Full self-driving is in early commercial deployment, but it is not fully autonomous in the way the public imagines that phrase. Robotaxi exists at a pilot stage with limited deployment depending on region and regulation. Optimus remains a company roadmap item, not a finished commercial product. Cortex and Dojo-style computing infrastructure exists in early commercial and developmental form, with the underlying technical approach still evolving. Fully autonomous manufacturing remains a roadmap ambition rather than current reality. And the fully integrated vision Tesla describes as sustainable abundance remains, honestly, speculation. So will Tesla actually connect every one of these technologies into one seamless machine? Or will this remain one of the most ambitious visions the industrial world has ever attempted without fully arriving? Here is the most defensible conclusion a fair investigation can reach. If Tesla succeeds completely, the world will not turn into, quote, a world of Teslas. It will become a world where more physical work gets mediated by software, batteries, autonomy, and robotics working together. The realistic outcome, even in an optimistic scenario, is a major restructuring of transportation, energy, logistics, and parts of manufacturing, not the sudden disappearance of cars, jobs, or public utilities overnight. Tesla may never execute every detail of this plan exactly as described. Timelines will likely slip the way they always have. Some pieces may fail outright, particularly around robotics and full autonomy. But even if only part of this vision becomes reality, the impact on transportation, energy, robotics, and industry could still be far larger than most people currently expect. Maybe the real question was never whether Tesla sells more cars next year. Maybe the real question is what happens the moment all of these separate technologies, energy, artificial intelligence, robotics, and manufacturing actually start working together at scale. Whether that breakthrough comes from Tesla, from a competitor watching closely from China, or from some company that has not even entered this race yet. If you want to understand what is coming for your garage, your job, and your city before it becomes the next headline everyone is scrambling to explain, that is exactly the kind of story we track here. So if this kind of investigation is useful to you, join us, because the next shift in this industry is not going to announce itself quietly.